welcome. And if you've seen me before this week, welcome back. I'm glad that the place filled up for this talk. I was going to be really shocked if we had more people for SQL CLR than we did for Transact SQL, but it looks like the place is filled up, so that's good. My name is Bob Boscheman. I'm Director of Developer Skills at a company called SQL Skills, and I'm going to talk for the next hour about optimizing procedures and queries in SQL 2005. I have about a day's worth of material here and about an hour to present it, and so I'm going to try and talk less and do more demos. But wherever I am at 11:45, we're going to stop this. We're going to go over to SQL Server 2008, and I'm going to show you the new Transact SQL features in 2008. So wherever I am, I'll just stop in the middle and we'll go there. There's the gratuitous self-promotion slide. I wrote 2 books on SQL Server. That's enough. We don't have that much time. So we're going to talk about how to optimize Transact SQL code, where to find the information to do optimization, why queries run slowly, how to find the information that you need, and how to fix them. So usually, the users point out when to optimize Transact SQL code. They either call you or come around and say, SQL Server is running slow, or my application is running slow. And you get to ask them at that point, is it everything? Is it just specific things that are running slow, specific queries? Or is it specific time frames, maybe around noon? There's very few people that get a chance to do this. If you get one of these, you're lucky, to do proactive optimization. In other words, before the users come around, you're optimizing already. What's running slow? Well, if the entire instance is running slow, then it might be best to do bottleneck analysis. And I'm not really going to talk about bottleneck analysis at all in this talk. But the way you would do bottleneck analysis is you start with this nice dynamic management view called SysDM OS wait stats. Now, the wait stats were around in SQL 2000. You got them with the DBCC command. And the nice thing about 2005 is that all the wait stats, it just shows you what SQL Server is waiting on. All the wait stats, I can't help myself. All the wait stats are all documented now. They didn't used to be documented. So select star from SysDMOS wait stats is a good place to start. And basically, these wait stats are cumulative from the time SQL Server comes up, and it basically tells you 207 things that SQL Server is waiting on. And we start with locks and latches. So, like I said, I'm not going to cover those in this talk. There's a really nice white paper called SQL Server 2005, Tuning with Waits and Queues. And if everything is running slowly, that's the best place to start. So now, which queries are running slowly? There's 2 trains of thought as far as which type of queries to tune. I like to tune the most frequently executed queries. So do a trace or look at the query stats and figure out which are the most frequently executed queries. The easiest way to do this, I have this set of diagnostic queries, is to go look at SysDM exec query stats. SysDM exec query stats will show you all of the queries in the cache, presently in the cache. So if you're in the unfortunate situation where they've been paged out of the cache, then you won't see them. But this particular view, and by the way, I'll post all this code afterwards, will show you all the queries in the cache. So far, there's only 1, and the execution count for these queries. So you can tell which queries are being executed the most frequently, and any goodness or any improvement you get out of tuning the queries with the big numbers here is going to be reflected that many times over. I'll get back to this dynamic management view later on. There's another way to tune queries, which is to tune the heavy resource consuming queries. Wait till the end of the month or the end of the quarter, and people run reports at the end of the quarter, and those reports usually take a long time. If you tune those queries, and a lot of times all you have to do is add an index, run the report, drop the index. If you tune those queries, though, you have a friend for life, right? The person that comes to you and says, my report that used to take 6 hours is now taking 12 hours. and I can't afford to wait 12 hours. If you can knock that report down to 1 minute, they're thrilled. So that's another way to tune queries. I'm going to talk about transactions and locks tomorrow morning. Another way to tune them is to look for queries that are slow because they're in lock waits. And tomorrow I'll show you some information about how to look for lock waits. So according to PSS, there's a bunch of guys in PSS, that's Product Support Services for Microsoft, and a bunch of folks from the product team wrote a book. And a couple of chapters in that book are about why queries run slowly. And these are the top 10 reasons why queries run slowly. And they're prioritized top to bottom. And I want to go over each of these reasons and give you an example of each one and show you how to tune these. So the first one is suboptimal physical structures. Not only things like, is the log on the same disk as the data is, but things like, could I do better with a partition view? Could I do better with a partition table? Do I have enough indexes? And the easiest way to look for these is a really nice tool that they have in 2005. It's right under 2005. Come on. Performance Tools, and it's called the Database Engine Tuning Advisor. I'm just going to run the Tuning Advisor really quickly. So this used to be called Index Tuning Wizard, but it's actually much better now. You can actually save the parameters that you use for tuning, and it saves them in an XML file, and you can even run this thing off the command line. So you don't have to get your GUI out to do this if you want to. It takes two possible inputs, a file, and that file can be a trace file, or that file can be a file of SQL queries, or a table. If you've actually loaded your trace into a table, then it will read the trace table. And I'll start by just bringing in a file of trace file there. Now, it can tune, as opposed to Index Tuning Wizard, it can tune more than one database at a time. And all my stuff is in AdventureWorks, and so I'm going to start in AdventureWorks and only tune AdventureWorks. Tuning options, it allows you to look for indexes and index views and evaluate only the existing physical design structures that you have, but it will also let you look for non-clustered indexes only or index views only. For partitioning, SQL Server has table partitioning. You can tell it whether you don't want to do partitioning, you want the indexes aligned with the tables, or you want to do full partitioning. And physical design structures, I was sort of scared of this one. Do not keep any physical design structures doesn't really mean that they will drop them all. It means that they will pretend there's no existing physical design structures. So we'll start with the defaults. Advanced options include, I only have so much space, so please don't suggest things that are bigger than a certain amount. And I'm running a 24/7 shop. Don't suggest things that make me go offline. In other words, don't change to partition tables if that makes me drop SQL Server and bring it back up again. So all offline, online when possible, and only online. So after you've chosen those things, the hardest thing about this tool is how to start it up. I'd expect the button down here. It's over here. So we'll start it up, and it's going to, by the way, while we're watching this run, don't forget to, you don't want to use this to tune a single query. If you use this to tune a single query, Database Tuning Advisor is fairly aggressive. And what it will do is tune the entire system around that query. You're telling it that that's the only query you ever run. It's the only query you ever care about. And it's coming up with some error messages, some gratuitous ones. It doesn't think that try-catch is correct SQL, which is wrong. And now it came up with a ton of suggestions, right? A bunch of them. Most of them are statistics, manual statistics, but a couple of them are indexes. And you can look at reports to see how often those indexes are used. There's 15 total reports. I'm not going to go over all of the reports, but you can do at this point 3 things with these recommendations. You can apply the recommendations, and I was afraid to push this button, but it says, do you want to apply them now, or do you want to schedule them for later? I don't particularly like the names that they give the indexes, and so I'd like to see it just as SQL so I can change the names. You can save the recommendations as SQL. That's kind of cool, and it'll ask you what you want to save. Or the last thing is even kind of cooler, which is it made, what, about 30 suggestions. And suppose I really only want to try 3. So we'll delete all of those, and we'll say I want this one, and this one. And then what you can do, once you've selected a subset, is to say evaluate recommendations. And evaluate recommendations, watch the stack of projects over on the left. Evaluate recommendations brings up another project with just those recommendations. And so you can tune using just the recommendations you choose, and then you can see the reports based upon your choices. So just your 3 choices of recommendation. Kind of nice. And like I said, this saves as an XML file, so you can tune these on a schedule if you want to. See if they come up with any other things. That's Database Tuning Advisor. Next one is missing indexes. And SQL Server 2005 has some really nice things for missing indexes. There are dynamic management views that let you see specifically what indexes SQL Server thinks are missing. And missing indexes include, or dynamic management views include, SysDMDB index usage stats, but then they also have missing index details, missing index group stats, and missing index groups. These statistics are cumulative. In other words, cumulative from when SQL Server starts. And in SQL Server 2008, they will actually have a performance data warehouse where you can store whatever you would like, including these statistics, in the performance data warehouse. So that's kind of a nice feature, allows you to look for missing statistics. There are also dynamic management functions. You can look to see what indexes you have out there, and these are those functions. Yes, sir? Index not used? You mean, the way to find indexes that aren't used is to look at Database Tuning Advisor, and it'll show you the indexes you have out there that are never used. That's the one where you say, don't keep any physical design structures and just tell me which ones are used. But you reminded me of something else that I forgot. Like I said, I'm trying to do a day worth of information in 1 hour, so forgive me if I talk a little bit fast. People hate to use Database Tuning Advisor because they don't want to use it against a production system. And you can use Database Tuning Advisor against a test system. There is a really nice feature in SQL Server 2005 Management Studio that allows you to make a statistics-only database. So if I go look at Object Explorer, connect to the database engine, and then left-click on any database I want to, let's do the pubs database. Under Tasks, I can choose Generate Scripts. And Generate Scripts has a feature, after you get past the wizard, there we go, that allows you to generate a database that has statistics but no data. And as far as Index Tuning Wizard is concerned, that's as good of a database as it needs. So you can take a production system, generate a test database that has only statistics but no data, and point Index Tuning Advisor against that, and it will think it's going against the live database. And the magic thing that you do to do that, or select to do that, is under Script Statistics option, you choose Script Statistics and Histograms. And it says, if you choose this, it'll take longer. That's fine. And then I want to just try a couple of tables to see how this looks. In fact, we'll just try one, the authors table. We'll do it, script to a new query window. And what he does is makes up DDL that creates blank tables, there we go, and also updates the statistics. And it updates them based upon the actual histograms from the live system. So now you can point Index Tuning Wizard and pretend that you have a live system where you don't have to use live system. Yes, sir? I don't believe it is possible in SQL 2000. I'm not sure of that, and I've never tried it against 2000, but I don't think it is. There are other ways, I think, to do that in 2000, but I'm not sure what they are either. Sorry, question was, is this possible against SQL 2000? The way I would try it is actually to look at a 2000 database through Management Studio and see if the same thing exists. Okay, because it's just filling in blobs of data. So one of the things, or one of the limitations of looking for missing indexes is that covering indexes aren't always reported as missing. And so I want to describe a covering index for you. And I'll go back to my original covering index thing. And I'm going to use the pubs database. I always use the simplest possible examples so that there'll be no, lack of clarity. So I look at the index on the authors table, and I notice I have an index in here called my index. That's left over from the last time I did this. So we'll drop that index. Otherwise, I have two indexes. Let's go back again now. And I have the clustered index, which is clustered around the author ID. Let's get rid of this so I have more room. And I also have a non-clustered index that contains keys of last name and first name. Now, by definition, the clustered index covers all the columns in the table. That's the one that you must use if you say select star from. And the non-clustered index contains not only the keys, the index keys, but the clustering key as well. So this is like a miniature table that contains last name, first name, and author ID. Let's see if we can use this to tune some queries. So select star from authors where last name equals White. You would think that since there's 23 authors, only one is named White, the cardinality estimates might be good enough to be able to use that index to cover the query, or use that index on the query. But if I go and look at actual query plan, you'll notice that he doesn't use that index at all. And you might think that that's kind of strange. He's just scanning through the entire table. The reason why he doesn't use that index is because for every author that he finds named White, he has to go back to the base table to get the rest of those columns. In other words, he just doesn't want first name, last name, and author ID, but he wants city, state, zip code, and those are in the base table. So he would have to do an equivalent of a join between the index data and the data in the base table. And he doesn't think it's worth it to do that. If I knock down the number of columns so that I'm only looking for AUID, first name, and last name, I can use that index. In fact, let's just do that in my query originally, just so you can see it's the same query. AUID, AUF name. And by the way, since I'm at the conference here, this is one of the things that sort of bothers me about both LINQ and the entity data model. If you do a query like that only looks at certain columns, you'll get an incomplete object. Or in LINQ, you'll get an anonymous type. Or in LINQ, you can go through and figure out what all your queries are and define objects over each group of columns that you choose to query. But the temptation is to just always do select star from, so you get a full object. And if you do select star from, you lose the benefit of covering index. And if I don't need city, state, and zip code, there's no reason to bring them back. So in this case, not only does he do an index lookup, but it's an index seek rather than an index scan. And all I had to do was use EFCOD's second law of relational databases, which is projection. In other words, don't select all the columns unless you need all the columns. Example of a covering index. Next. Lack of indexes on computed columns. This is taken advantage of a new feature in 2005, and I'll talk about this feature. Some of these were available in 2000. I'll show you the difference. So I've made the simplest possible table that I can make. A sales table in the TempDB database, which has a quantity, a product, price, and a total. And notice the total is whatever the product price times quantity is, plus the Redmond sales tax. Okay, that's actually what that is. And of course, yeah, I can't drop it, it doesn't exist. Insert only 5 rows in there. And by the way, notice I do have a primary key, which means I have a clustered index on sales ID. There we go. So select sales ID and total from sales where total is greater than 20. Well, total is a computed column, which means he'll have to do that computation every time I execute this query. Let's have a look. Look at the query plan for this, and you'll notice that the execution plan contains a couple of computations. There's a computation over here, compute scalar, and there's also a computation in here, if you look under the word predicate. It's doing the convert to decimal, convert implicit, numeric, and then actually doing that computation as part of the predicate. Because, of course, it is part of the predicate, total greater than 20. And he has to do that same computation each time. By the way, if you're looking at query plans, I always wondered which scalar operation I was doing in compute scalar. One of the ways you find this is to click on the scalar operation and then say View Properties window. There's only so much that they can put in hover over help, right? So some of the stuff that doesn't fit in hover over help, like the actual computation, that's what they're computing. You can get from the properties window. So don't forget about the properties window. Okay, back to the original problem. I don't really want, since the total price never changes unless the price or the quantity changes, I don't really want to calculate that each time. And what I'd really like to do is I'd like to have an index on the total. Now, since the total computation is deterministic and precise, I'm only using decimal data types. Since it's deterministic and precise, I can do this in SQL Server 2005. And if I use the persisted keyword, it will calculate that total only when the total is inserted or when the total is, the price or quantity is changed. So that's persisted. But either in 2000 or 2005, I can do better than that. I can put an index on the total. And now we have sales ID and total in that index. An index over a computed column. There. Now suppose I actually started off with a table that didn't have a computed column, and I added a computed column. First of all, let's make sure that index gets used. There's the query plan now. There he is. And notice that now it looks like a little bit more complicated query, but it actually is a much quicker query. You can always look at the estimated subtree cost in the iterator at the left to tell the entire size, the entire cost of the query. And notice he is using that index right down here for an index seek. So it was a good idea to put on that index. But people will say, Bob, I don't have a computed column in the table. And I can put the computed column in, but if I put the computed column in, I have all the computations actually done in line. I have queries that look like that. And is SQL Server smart enough, if I make up a computed column over this formula right here, is he smart enough to use that column? Or do I have to go and change all of my queries to use that column? And it turns out, like the comment says, in SQL 2005, you can make him smart enough to use that column. Remember that this is what the query plan looks like if he uses the index. So let's see if he uses the index right now. And it turns out that he does. He uses the index even though you don't name the column by name. He is smart enough to go and match the formula in the column to the formula that you use in the query. Now, it turns out, I sort of stretched the truth a little bit here. The reason why is because I'm using something called forced parameterization. If I alter database tempdb to set parameterization to simple, which is the default, he doesn't use that computed column anymore. There, the query plan is different. But if I change it to use parameterization forced, which again is not the default, he knows enough to, forced with a D, he knows enough to use that column, that index. There. Yeah, we'll show there we go. So index on a computed column. And you don't have to have the computed column in your database already. Next, out-of-date statistics. So SQL Server keeps statistics on both indexes and on columns. And by default, SQL Server keeps statistics on columns, single columns, automatically. And in fact, let's go forward a couple of slides. We'll go past that too. There. Now, SQL Server by default will keep automatic statistics if you have auto-create statistics turned on in your database. It will automatically update those statistics if you have auto-update statistics turned on in your database. Now, one of the drawbacks of this is that way that he updates statistics. If you go back to that query plan diagram I had, because I'm not going to go over every slide in this talk, as part of the query plan, he looks to see if he needs to use statistics. And when he does that, he looks to see if the statistics are out of date. And if the statistics are out of date, he determines that by the number of rows that have changed. In SQL Server 2005, he can actually track the number of times a column has changed. So if you have statistics on city and statistics on zip code, and the city has never changed, but the zip code is, unlikely. I should have chosen a better example. Then he won't update the statistics on the one that hasn't changed. And he does it on a column-by-column basis. But the problem with the way that this works is he does it right in the middle of making up the query plan. Oh. So the person who's doing that query is going to have to wait while he updates statistics. And sometimes people don't like that. It looks like blips in the query, right? The query runs fast, runs fast, runs fast. Oh, wait a minute, it's run slow. So in SQL 2005, there is another option called Auto Update Statistics Async. And what that does is it sacrifices that one person. The one person that would wait for the statistics to update is going to get a bad plan, an out-of-date plan. However, they will spin off a thread to update those statistics in the background. So this person might get an out-of-date plan, but at least he's not going to have to wait. And by the time the next query comes in, the statistics hopefully will be updated. And that's Auto Update Statistics Async. Now, let's have a look at some statistics. It turns out in Management Studio, you can even see them in the GUI. So let's go back to the pubs database over here. And under Tables in the graphic user interface, if I choose a table at random, like authors, notice that I have columns and keys and constraints, blah, 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 and statistics. Let's look at statistics. There are two types of, like I said before, statistics. Statistics that SQL Server keeps automatically are easy to spot. They all start with _WA _sys. I don't know why, but they do. The ones that they keep for indexes are named after the index. And so let's look at the one on our last name, first name index. Click on that, say properties, or choose properties, and notice that there's the statistics, tells you which columns they are, and if they are index statistics, it will even show you the density buckets. There's the density buckets right there, and the cardinality histograms. There's the cardinality histograms right there. So in other words, how dense is the population around a certain key, and also how many rows are in each bucket. And SQL Server can only keep up to 200 histogram buckets. And so notice we only have 23 now. So that's kind of cool. You cannot do this on statistics that, or you cannot see this on statistics that he keeps automatically. So there's that. But you can see them in SQL Server. Let's make one happen. What was the statistic on here? It was on city. So let's have another statistic. Select star from authors. Remember, this is a 23-row table. SQL Server is fairly aggressive about doing these. Where state is equal to CA, California. Go. Okay. We'll refresh the statistics. And notice he's made already another statistic. And you could probably guess that that statistic was around California, or state, sorry. There it is right there, the statistic on state. And so you can watch SQL Server keeping statistics. Now, if you don't like the way SQL Server keeps statistics, say, for example, you have a table that is really a queue, and the application goes in and adds, and deletes from that queue, those statistics will never be up to date. And they'll be constantly recomputing those statistics because the statistics, the table is constantly changing. SQL Server will recompute statistics on the 50th row you add, the 500th row you add, and if 20% of the rows change. And that's actually documented in a white paper called Statistics Used by the Query Optimizer. If your table is in TempDB, they will also keep statistics on the 6th row that you add. So 6th, 50th, 500, and 20%. Again, that's documented. You don't have to write that down or anything. The papers are actually listed in the back. If you don't like the way they keep statistics, you can turn them off. Now, unfortunately, well, the way that it works is that you can, I always say unfortunately, like there could be something better. The way that it works is you turn them off on a per database basis. People always ask me, is there a way to turn off statistics on a per table basis? And no, there really isn't. SQL Server will also only keep automatic statistics against single columns. If you want multi-column statistics, you keep them yourself. And the way you keep them yourself is that you can say create statistics, which is the new cool way that uses DDL. SP create statistics was the old-fashioned way that uses a stored procedure. You can do a manual update of statistics, and when SQL Server defines them automatically or updates them by default, the amount of rows that he actually samples is 1 over log n number of rows. He doesn't sample all of the rows, right? 1 over the logarithm of the number of rows in the table. So if you want him to sample more rows, or for some reason less rows, then if you automatically create or update statistics yourself, I mean manually update or create statistics yourself, you can name the sampling number. I want you to sample 50,000 rows, or you can use the sampling percentage. I want you to sample 50%, or you can say with full scan, which says sample all the rows in the table. So if you create manual statistics, it's up to you how you want to do that. I wanted to show you a SQL Server specific feature in 2005 that I thought was cool. In SQL Server 2005, they will actually keep statistics on substrings in a string column. Normally, in 2000 and below, this query, where a last name like BEAU with a wildcard on each side, cannot use the index, obviously, and cannot use the statistics. In SQL Server 2005, this query can use the statistics. And I want to show you this one because I didn't believe it. Remember, I said I never believe what I'm told. I have a database called the credit database, and I want to show you there's an index on the member last name, which is a varchar column. And if there wasn't, I would create one. And I want to show you that there's 10,000 members in the table. There we go. Now, let's select star from member where last name is like BEAU with a trailing wildcard. That one can use the index, and that one can use the statistics. And we'll have a look at the query plan for that. There we go. Here's the query plan for that. Notice I've done a couple of different things, and so I got Kimberly's name in there too. Notice that SQL Server is so aware that there are few rows that they will actually do that kind of query plan that I talked about last time. I said select star from, so they can't use the last name index as a covering index, but they can do an index seek on that index and then go do what used to be called a bookmark lookup, which is now called a key lookup, or an RID lookup if you don't have a key, in SQL 2005. And basically what they're doing is a nested loop join between the index and the rest of the table. They would only do something like that if they know there's very few rows in the table. If there's a lot of rows in the table, they would use an index scan, a clustered index scan. So let's see how smart they are. So what was this? 6 rows in the table out of 10,000? Let's up the ante a bit. So first of all, let's use our query that looks like this. If they're not using the statistics, I should see clustered index scan. If they are using the statistics, I should see that nested loop. And lo and behold, they are using statistics, even on a wildcard predicate in both sides, which is amazing to me, right? These would never use the statistics before. How could they look at statistics on a leading wildcard, right? So we'll bump it down a few more and see if they can notice this. And by the way, of course, this will change the result. Now I have 1,461 rows. And let's see what they do for an execution. They're back to clustered index scan. So the idea is that they not only keep statistics on the column, but if it's a varchar column or n varchar column, they will keep statistics in 2005 on substrings, so that some of the wildcard predicates with like will actually be able to use the statistics. I think that's a really cool feature. All righty. Let's go back and talk about plan reuse. Plan reuse is usually a good thing. And the reason why plan reuse is usually a good thing is because to create a query plan takes CPU time. In fact, if you've got a huge honking CPU and you seem to be taking too much CPU time, perhaps it's because you're recreating too many query plans. SQL Server 2000, if I have a stored procedure with 10 queries in the stored procedure, so procedure A contains 10 queries. The first time control enters that stored procedure, they will make up query plans for all 10 queries. And if any of the statistics for any of the 10 queries change, they will recompute query plans for all 10 of them. Really. This is known as procedure-level recompilation. And in SQL Server 2000 and below, they have always done procedure-level recompilation. People are maintenance programmers. Did you wonder why people do crazy things like having 1 query per stored procedure? That's why, right? I don't want to make up 10 query plans because one of the queries change. I want to make up 1 query plan if one of the query changes. So a way to get around that limitation was to have 1 query per stored procedure. But if you don't need to do that, it makes the code harder to read. So in SQL Server 2005, for the very first time, they actually do statement-level recompilation. Over that again. 10 queries in procedure A. First entry into that procedure, they make query plans up for all 10. If one of them changes, they only recompile that one. They don't recompile all 10. So that's a fairly drastic change and might actually affect how you would structure your code in 2005. I want to show you where this sort of manifests itself in SQL Server Profiler, and I apologize for some of the dialog boxes in Profiler. I can't resize the font. New trace against 2005. Look at the events. Show me all the events. In 2005, you can get the stored procedure recompile event, but it's sort of misleading. They're only recompiling the one thing that has changed. In 2000, that's the only event that you can get. However, in 2005, I thought this was a cute way to put it. They said, that trace event has been deprecated. Okay? It's there because people would use this utility against a 2000 database. On 2005, you should use SQL statement recompile instead. So a big difference, big change, might change the way you run your code or you structure your code. Okay. So plan reuse is usually a good thing. And plan reuse is achieved by using stored procedures. That will reuse the query plan because the query is hard-coded in the stored procedure. It won't help if you use a stored procedure that does dynamic SQL. They can reuse the query plan for SQL, but it's not as often. Using parameterized queries or something called auto-parameterization. And I want to demonstrate auto-parameterization. I start over here with a bunch of queries. And what I'm going to do before I start, let's get rid of some of these superfluous windows there, is to bring up my diagnostic information. Now, this is way overkill for what I need to do. Take a checkpoint. Free proc cache, DBCC free proc cache, you don't want to do this on a production system. Free proc cache will get rid of every query plan in the cache for all databases. A little bit more surgical way to go about this is to say DBCC flush proc and DB, and that will only flush the plans for that particular database. And then I'm actually going to go one further. I'm going to drop all the data buffers. Again, something you never want to do in a production database. There. So if I go look at the query plan cache right now, I have no query plans in the cache. Great. So I can follow the query plans in the cache as I go along. So go back to my auto-parameterization, and we'll go to the pubs database, and we'll do this select. What did I just do? Just go to the pubs database up here, smarty. We'll go and we'll have a look at this query, and we'll see, does SQL Server auto-parameterize the query? And it says no. There are some queries that it actually won't auto-parameterize. Now, what is auto-parameterization in the first place? Well, rather than describe it, because it's a long word and I get tired of saying it, let me show you it in the query plan cache. Execute. Now, go look at the cache. Notice that we have a couple of query plans in there now. One for this particular query. Let's get rid of the query plan for that particular query there. And one for something that selects DTB name, which is looking for metadata. And there's my query plan right there, and we have an execution count of 1. Let's show what happens when I reuse that plan. There. So the execution count should go up to, I messed that up badly. Let's try that again. You have to select them, Bob. All right, so now I have nothing in my cache. Execute this, go back here, and see what's in the cache. There. Oh, let's get rid of all of them again. This is something, of course, you want to do on a test system in your spare time. There. We'll make sure we select this so I don't execute every query in the place. Thank you. There we go. And now I have nothing in the cache. Go back here, over here, back to here, one query in the cache. And notice that there is no auto-parameterization. Auto-parameterization would replace the number 30 by a parameter. We'll see this in a second. Notice that if I execute exactly the same text again, they will reuse the query plan. So now it has an execution count of 2. By the way, how do they match this text if they don't do auto-parameterization? They match it with string compare. Really? Let's add a gratuitous comment. Is that now the same query as the other one? You would think so. But they're doing string compare. So watch this. Different plan. I always wondered why people that code up SQL statements in programs make them constants at the beginning of the program. That's why. If you have an extra, if they're doing string compare, and you have an extra space or a carriage return line feed, it doesn't match, right? That was a comment I put in. That shouldn't have made any difference, but it did. So what about this auto-parameterization again, Bob? All right, so here's the query. Select star from titles where price equals $19.99. And this is simple enough. It's not a having, it's a where clause. And so what you'll see in the cache is an auto-parameterized query, this one right here. They've changed it to select star from titles where price equals @0. and they've defined a parameter @0 of type money. How did they decide it was money? They decided it was money because I had a $sign in the query. Oh, okay. That's a kind of strange way to decide. So will they use it if there's a different value? So $9.99 now. And yes, they use it as if a different value. Execution count is equal to 2. So SQL Server, even if you don't use parameterized queries, will parameterize some of the queries for you. Okay, but how did they choose the data type again? And is this really a good thing to depend on? Let's look at this one. This is $7.99, but look what I did. I dropped the $sign. Same query? No, they have a new one. Numeric 38,2. Lovely. So that means that that query specifically, and by the way, the only reason why that's true is because I have force parameterization. Let's take force parameterization off. Parameterization simple. I can't spell parameterization. Parameterization. It turned blue. Okay. By the way, changing anything with alter database clears the cache. Okay. So now I've cleared the cache for that database. Here's my one with a $sign. And I'll go back and see that this one now should show one query in the cache, and it's auto-parameterized as money. Go back to here, and here's my one without a $sign. This one is now auto-parameterized as numeric 3,2. 3,2, how did they get that? They read the value. Well, you mean that if I go back here and change this to $17.99, that's now 4,2? Yep. There. Notice that I have as many query plans as I have as many different numeric precisions and scales. Lovely. If he's auto-parameterizing integers, I get one plan for tiny int, small int, and big int. So although auto-parameterization looks cool at first, I wouldn't depend on auto-parameterization if I had a choice. You always want to parameterize your own query. Having said that, if you do need to go with dynamic SQL, there's two ways to do this with dynamic SQL. One is to use exec, and exec just executes a string. The other one is to use SP-execute SQL. And you can see the goodness of SP-execute SQL without me even executing the query. In SP-execute SQL, the second parameter to SP-execute SQL is data type pairs. So parameter, data type pairs, and now I've always named that data type to be money. So regardless of whether or not I do this, this explicit parameterization prohibits the automatic parameterization. And I will always get the right thing, and I always reuse the query plan. So that's something to remember about auto-parameterization. So plan reuse can be achieved by auto-parameterization. That's probably the worst way to achieve it. Why did they put auto-parameterization in? Suppose you have bought an application, and that application does not use parameterized queries. And you cannot change the code because it's somebody else's application. You bought it. Well, then, auto-parameterization is your friend. Plans can be aged out of the cache using under memory pressure. So there's a bit that says I've run out of memory or I'm about to run out of memory. SQL Server turns on that bit. And like I said yesterday, when he turns on that bit, a couple of things will happen. He starts throwing away plans out of the cache. He starts throwing away data buffers. And if you have .NET code, he causes a .NET garbage collection. That's memory pressure. And by the way, there are 3 caches, one cache for stored procedures, one cache for ad hoc queries, and one cache for .NET queries and extended stored procedures. Those 3 caches are managed exactly the same. I wanted to use this as an excuse to talk about, I know said I wasn't going to do much talking, but to talk about the big question that everybody always asks. Are stored procedure plans kept in the cache for longer than dynamic SQL plans? And the answer is usually no. Stored procedure plans are kept in the cache for exactly as long as dynamic query plans. They use exactly the same algorithm to get rid of them, but the algorithm has to do with how expensive the plan is. You saw how we could see a plan cost there. Let's talk about how expensive the plan is. So if I go look at a query, the query is actually stored. Let's execute a query. Oh, we have one. All right. The query is actually stored with the plan cost, usually, right there. And the plan cost is, in this case, the estimated subtree cost from the iterator at the left. That's 0033018. So when they start to throw plans away, they throw the ones with the smallest number away first. The only distinction between stored procedures and dynamic SQL is if you use non-parameterized dynamic SQL, the first time you execute a query, they store the plan in the cache with a cost of 0. The second time you execute that same query, it catches up. So say the plan cost was 003. If that plan was in a stored procedure or in a parameterized query, and auto-parameterization counts, they store the plan with the exact plan cost, 003. If that plan is not parameterized at all, they store that plan with a plan cost of 0. And only the second time that it's used do they actually up the plan cost to the right amount. So that is the only distinction. And as far as I'm concerned, it's a minimal distinction between using dynamic SQL and using stored procedures. And again, this becomes a big deal with the advent of LINQ and the entity data model, which will use dynamic SQL in their queries. So unless you use, and both of them use parameterized dynamic SQL, in that case, there is no difference. Comes up every once in a while. Everybody spends a lot of their time arguing about it. You can experimentally determine it. There are changes in Service Pack 2 for plan cache size and plan cache choices. And this is good because originally in SQL Server 2005, they rewrote the plan cache. And they decided to make the plan cache or allow the plan cache to get bigger than they had allowed it to get in SQL Server 2000. Problem with that is it got too big. If you have a lot of dynamic SQL, you could fill up the plan cache so that you were constantly running under memory pressure. Oh, great. So in Service Pack 2, they put some limits on the algorithm that grows the plan cache, and it won't grow as much anymore. 3 kinds of plan cache. I talked about this. Query plans are reentrant. Execution plans are also cached. Let's talk about this. Let's go back a bit. I'm sorry, I'm just going to stomp all over my slides because what really matters is the demos. Okay. If I go to make a query plan, the first thing they do is parse the statement for syntactic correctness. They look in the cache and they see if there's a matching plan. If there is a matching plan, then they use it and they go down to here. If there isn't a matching plan, they go through query optimization. So query optimization consists of parsing again, doing auto-parameterization if they need to, binding and expanding views, right? A view is just a different name for a series of SQL statements. And so they change the view and to the SQL statements that it composes. Then matching the statistics and costing the plan. Basically, when they cost the plan, they have a 4-step process for costing the plan. Here's the 4-step process. Step 0. If it's a trivial plan, they just give you back the plan. What's a trivial plan? Select star from authors. That's a trivial plan. There's only one plan, right? That's easy. Go on to step 1. If there are 4 or more tables in the query, they take a subset of the matching rules and they try to get a plan with a plan cost of under 0.7. And this is all documented, right? And if they get a plan cost of under 0.7, they stop. Step 3, they take all the statistics and all the matching rules and they try to get a cost under 1. And the first time they get a cost under 1, they'll stop again. Step 4. When you're down to step 4, you're down to the last step. And that's like playing chess with a computer with a clock. Anybody play chess with a chess clock? Right? You have so much time to make a move. Well, they have so much time to produce a plan. And so they just produce plans until the timer runs out. And when the timer runs out, they take the one with the lowest cost. That's how they produce a plan. Now, once they've got the plan produced, then they generate what's called an executable plan. There is a difference between query plan and executable plan. A query plan is a static structure that is both reentrant and reusable. In other words, 6 people, same query, same time, can use the same plan. However, an executable plan, this one down here, is per person. So it is reusable. I can reuse it after you are finished with it, but not reentrant. Multiple people cannot use it at the same time. And the reason why is the executable plan contains things like your parameter values, which are different for every query, even if you're using the same plan. So once they generate the executable plan, they go on to fix up what's called a memory grant and degree of parallelism. Now I'm going fast here because I got 3 minutes before I switch over to my other VM. Some of the iterators in a SQL Server query cost memory. Order by is one of them. So order by price. If I put in order by price in here, my query plan looks a little bit different. First of all, let's do it without order by. There we go. And my execution plan looks like this. If I look at the select statement, notice what I have. Cache plan size, degree of parallelism, estimated operator cost, estimated subtree cost, estimated number of rows. Just memorize how many rows we have here. 1, 2, 3, 4, 5. Now, let's put an order by in. Order by should cause a sort. And now when I go back and look at my plan, didn't cause a sort. That was rude. Let's try order by something else. Did I miss order by price? That's ordered scan. Oh, how nice. Okay, that was rude of them. So let's do select star from authors, order by city. There, smarty. There we go. I hate when the optimizer is smarter than I am, which is almost always, right? Okay, order by city. There. Now what I should find is a little bit different plan. There we go. We got a sort in there. Now, a sort is a specific kind of iterator that stops the query right there. It has to stop the query to do the sort, but it also takes memory. It takes memory to do the sort. And so now if I look at my select statement, notice that I have an extra column here, extra row, called memory grant. SQL Server tries to estimate how much memory he's going to need to do the sort and allocates that memory up front because allocation of memory is expensive. If he guesses high, he's wasted memory. If he guesses low, he has to allocate memory during the query itself. So query, it's half done, malloc. Another part of it, then malloc. Then another part of it, allocate some more memory. Right? That's going to slow the query down. So that's what a memory grant is. The 3 iterators that commonly cause memory grants are sort, hash join, and hash aggregate. Hash join is a special kind of join plan where they create a hash table over one of the tables and then read the hash table. I'll show you one of these coming up in 2008. So hash joins and hash aggregates take memory, and sorts take memory. Okay, great. So This is the executable plan, and then they fix up the memory of the degree of parallelism and go. All right, I should really switch over now, but I want to show you all the different things that you can use for diagnosis, and then I'll switch over to 2008. So we already looked at sysdm exec query stats. Sysdm exec query stats gives you query statistics, one per plan. And notice they give you a SQL handle, which is an opaque pointer to the SQL, and a plan handle, which is an opaque pointer to the plan. Notice the kind of statistics you get. Not only the execution count, but the total worker time, the time that they spend on the query, the total number of physical reads, the number of logical reads and writes, and if you're using .NET code, even the amount of time spent in .NET. So this is, I think, one of the most useful views to allow you to see what's going on in your queries. And by the way, there's another good one I almost forgot, total elapsed time. So they'll give you the amount of time that the queries took. Now, SQL Server doesn't put all the query plans in here. He only puts query plans in here that he actually uses. What do you mean actually uses? Well, if I have multiple processors, he will always make up one parallel plan and one non-parallel plan. And he chooses the degree of parallelism at the last minute by how busy the system is. So if you want to see all the query plans, they won't be there. All the query plans live in sysdm exec cache plans. Now, they show you all the query plans and what type of plan they are, and whether they're for a prepared statement that's stored procedure or ad hoc query, but they don't give you statistics about how long they take. How do you see executable plans like this? There's my query plan, but also my executable plans. The ones that are null under cache object type are query plans. The ones that are not are executable plans. Okay. How do you know what causes them to reuse a plan? This is called sysdm exec plan attributes. So if I go back and get a query plan in general, and by the way, notice that I use these two dynamic management functions to be able to get the SQL statement from that handle and the query plan from that handle. And that's the exact query plan in XML format. What I want, though, for plan attributes is the plan handle as a number like that. So copy that in, look at sysdm exec plan attributes, and paste it in. And now you'll notice that these are all the attributes of a plan. Now notice there's an extra column here called isCacheKey. If isCacheKey is 1, all those attributes have to match, or he will not reuse the plan. So if you have a query but a different database is executing it, or a different language, or a different date format, those guys won't reuse the plan. This is the most important one, by the way, to look at, set options. Set options are options on a session, like set ANSI nulls on. Changing the set options can cause plans not to be reused. Great. I want to quickly point out one more, and then we'll switch over, which is user ID. In SQL Server 2000, they actually match plans by user ID. So Bob gets a plan and Mary gets a plan. Those can't be the same plan. In SQL Server 2005, this is really default schema ID. So if Bob's default schema is Bob, he gets a plan. If Mary's default schema is Bob, she can use the same plan. Default schema ID. Am I going too fast? It's because I'm running out of time. All right, I got 10 minutes. I want to move over to SQL 2. So let's just go over one more time the reasons why queries run slow. And by the way, I'll give you this code so that you can run this at home or wherever you work. A lot of people don't run queries at home. Maybe it's only me, right? 10 reasons are suboptimal physical structures, use Database Tuning Advisor. Missing indexes, there are ways to find those. Lack of covering indexes, showed you one of those. Lack of index on a computed column, showed you one of those. Out-of-date statistics, didn't show you out-of-date statistics, but up-to-date statistics. Non-parameterized queries, those can cause excessive compilation time let's talk really quickly, like for 1 minute, about parameter sniffing. By the way, overly complex queries says that although SQL Server can do 256 tables in a single join, if you use over 20 tables, his chess clock is going to run out of time too soon. So try not to use more than 20 table joins in your queries. People laugh, but I've used 20 table joins to produce a name and address list. It depends on how strong your database designers are. You got database designers that design to fifth normal form, that's what's going to happen. Let's talk about parameter sniffing really quick, and then we'll go over. So parameter sniffing works like this. First of all, SQL Server will never use in the query plan something like this. If I set this variable in code, they don't use that variable inside the query plan. Let's have a look at the plan, and I'll show you why. So there's this thing used in code in the right database, Bob. Sorry, I think this one is worth it. There. And we get an execution plan that contains a merge join. And when I look at the number of rows they think they're going to get going into the merge join, it's 9,500 rows. If I look at the number of rows that actually come out of the join, it's 96. He's off by a factor of 100. Oh, how come he's off? Because they never use the statistics based upon this number. They're just guessing. So if you set a parameter in code, they don't use it to make the plan. Really? Well, let's do this with a stored procedure. Here's a stored procedure, right? Or let's do this with a hard-coded query. Here's a hard-coded query. Hard-coded query, they will. Really. 96 rows affected, plan changed to nested loops. Nested loops are usually better for a small number of rows. Merge join is better for medium number of rows. They're now using the number. Stored procedure, let's do stored procedure. Here's stored procedure. Stored procedure, they'll use it too. Here's a stored procedure. That's fine. I want to drop it just to make sure I didn't change it. You can tell I used the same virtual machine before, perhaps. There. Make up the procedure. Execute the procedure. If I get nested loops, it's the right plan, and it is the right plan. So the reason for this is because on entry to a stored procedure, SQL Server creates the query plan. The key is on entry to a stored procedure. On entry to a stored procedure, he knows what this parameter value is. It's this. However, if you set it after he parses the batch, like here, he's making up the query plan for this batch right there. And he doesn't know what that parameter value is. So sniffing the parameter value on entry to a stored procedure is called parameter sniffing. And while I switch over, that's usually a good thing, right? Because it'll use the statistics to figure out the right plan. While I switch over, I will tell you what the bad thing about parameter sniffing is. All right, so parameter sniffing is usually good. Let's go to the, serves me right for trying to do 1 day's worth of stuff in 5 minutes or an hour. For SQL Server 2008, there we go. The new features that have to do with query optimization are query optimizations for star join queries. In other words, to make the analysis services queries run faster. A resource governor, so you can decide, you can split your SQL Server into workloads and decide which workload gets how much. Plan stabilization, you can make up and save the query plans from 2005. And if the 2008 query plans happen to go slower, you can make 2008 use the 2005 plan automatically. Filtered indexes and filtered statistics. This is, I only want to create statistics if the number is greater than 100. So create statistics, but only on those rows where number is greater than 100. Anybody have sparse columns? In other words, a column where half of the values are null. Why bother to create an index on half of the values being null? So filtered indexes, filtered statistics. Sparse column support is also in 2005. Transact SQL features, table valued parameters, merge statement, grouping sets, and row constructors. So as I'm moving over to show you these, I got 5 minutes. You can tell I'm panicking for time here. While I move over to show you these, there we go, what I want to tell you is the hazard of parameter sniffing. Suppose I have a store, and the store has 10,000 customers, and I've just opened a branch office in Australia. The Australian people will get in first to do their queries. But I have 10,000 customers in the US and 5 customers in Australia. If the Australian people get in and do the query first, the query will be optimized for 5 customers, nested loop join. When the American people get in and do their queries, because of time zone difference, they always get in later, they will use that query plan optimized for Australia. So that is the hazard of parameter sniffing, right? They never change the plan unless the statistics change or the metadata change. They do not change the plan when you change the parameter values. All right. Here's merge. Anybody ever want to do merge? So this is merge in 2008. Create a table called customers and insert some rows. Oh, by the way, these rows use something called row constructors. Notice that I can insert more than one value at a time. This inserts 4 rows. I just put parentheses around each row and a comma at the end. So insert 4 rows. Create another table called quarterly update. I used to work on a payroll system. And every month we would send a tape to the insurance company. Yes, I remember tape, right? We used to send a magnetic tape to the insurance company with the insurance changes. So-and-so got married, their insurance changed. So-and-so had children, their insurance changed, and so forth. So these are the updates that go into the insurance company. This is what the insurance company sees today. This is what the insurance company wants to apply as updates. However, there's also new employees, and there's employees who have quit, right? If it's a new employee, I want to add them. If it's an update, I want to do an update. If it's a delete, I want a person left, I want to do a delete. That's what merge does. Here's merge right here. Now, this looks fairly hideous and awful, but let me describe what it's doing, and then I'll tell you how it does it. Merge customers, that's the master table, using quarterly update, that's the merge table, on C customer ID equals Q customer ID. If they're matched, then do an update. If they're not matched, then insert. Okay, so how does that work? Well, let's see how that works. Query plan. Ooh, I might not make the query plans big enough to see. All right, I'll have to describe it if that's true. Go. So first of all, it did the merge. It actually spit out what happened, inserts or updates. And let's look at the query plan. Notice there's a new iterator called clustered index merge and long query plan. The way that this actually works is they're doing a join between the 2 tables. Now think about your join. You got your inner join where there's a row in A that matches a row in B. So the inner join part is applied to when matched, right? That's the inner join. You got your left outer join, which says there's a row in A, but not a row in B. Okay, well, the left outer join part is applied to the not matched. Big surprise. There's one more here, which is I want to be able to delete. So here's some more in quarterly update. Delete quarterly update all the rows, and here's the next quarter. This says update when source not matched or when target not matched. So think of your full outer join. Full outer join has the people that are matched, the people that don't match A, and the people that don't match in B. So the people that are matched get to go here. The people that aren't matched in the source go here. And the people that aren't matched in the target go here. Okay, and pretty much I can do this in one statement. which is what people have always wanted. There. Nice feature, 2008. I'll show you one more feature, which is kind of cool, and the reason I switched over to this VM is so I can show you this parallel query plan. Anybody ever heard of an Oracle bitmapped index? Anybody ever wanted one? SQL Server makes bitmapped indexes too, but only if you have a parallel plan. And they make them up on the fly. You are not allowed to create one yourself, but they will make one for you. 250,000 rows. Here's a query. Let's look at the plan. There. The execution plan for that query is going to use parallel processing. See the parallelism operators in there? That's why I switched over to this VM, by the way. I have parallel processor, but virtual PC can only see one processor. Oh. So I switched over to this one so that you could see the parallel plan. But let's go back over here and notice that he's decided that it was worthwhile for him to create a bitmapped index on the fly. So he did. Bitmap create. Now, he's doing that, of course, on a separate thread than he's actually doing the main query on. So I think a bitmap index is okay, so we'll create one over here while I do the query over here. Cool. But he could do that in 2005. What the distinction is between 2005 and 2008 is I can create multiple bitmap indexes per query if I decide that I need them. So what this query is a big honkin' data warehouse query. It's so big that he's decided to make 2 bitmapped indexes on the fly. One more? I'm 1 minute over. Let's see if they let me get away with this. One more. What do I have for one more? Grouping sets. Fact Internet Sales, grouping sets. Group by product key, one set of groups. Group by product key in one dimension with rollup. Anybody use with rollup? Actually gives you subtotals. There. If I look at the execution plan for this, there's a stream aggregate someplace. Sorry. There's a table scan for 1. There's only 1 in here. This is the equivalent of this, but in other words, this query is the equivalent of the query above. So this one is the same as the one I just did. But notice there's only 1 table scan here. To get the subtotals, he has to do another table scan. Notice that if I did it the old-fashioned way, he'd do more than 1 table scan. Grouping sets. Where's grouping sets? Grouping sets are a way to be able to, I'm flashing red here. Grouping sets are a way to have you be able to do more than 1 group by in a single statement. So there's 3 different subtotal groups here. I'm only going to do 1 table scan. And the nice thing about this is they were actually even able to parallelize that it was so big. So you might think, why would you ever want to do more than 1 group by in a single statement? Anybody use reporting services? In reporting services, there was the table and there was the matrix. In reporting services 2008, there's something called the tablix. Grouping sets, I think, exist to feed the tablix. What does the tablix do? Arbitrary group bys. Cool. All right, that's all I have time for. So if you do have questions, see me after the talk. The slides are available for you. The code will be available for you on the SQL Skills website. So go to www.sqlskills.com, he said, and look under past conferences. So, oh, lovely. SQLskills.com. And I thank you for coming. Don't forget to fill out your course evaluations. And I'm sorry I ran out of time, but, you know, only an hour and a half or hour and a quarter. Thank you.